Morning, my name is Josiah Coop. I'm here on behalf of the Poultry Club to introduce Dr. Doug Korver. Doug is a poultry nutritionist at the University of Alberta, a position he has held since 1997. Doug teaches animal and poultry nutrition and gives talks at scientific and industry conferences around the world. He is a member of the committee to update the 1994 NRC nutrient requirements of poultry. Please welcome Dr. Doug Korver.
Thank you. Thank you to the Poultry Health Research Network. Can everybody hear me okay? Yeah? Thank you to the Poultry Health Research Network for inviting me here. It's good to be back in Guelph. I've been here many times and it's always a good visit. So, as was mentioned, a lot of the focus when we talk about the first 7 days of a bird's life, we generally focus on broilers, and so that's going to be the focus of my talk, but I think as it relates to turkeys, as it relates to layer pullets, as it relates to broiler breeders, these are concepts that we can apply. And the physiology, in a lot of ways, there's a lot of similarities, even though there are some great differences. So I'm going to focus my talk on broiler chickens, but if you're in a different commodity, I think there's hopefully some messages for you as well. So the context we have is that the poultry industry is expanding both globally and nationally, and by next year, by 2021, globally poultry will be the #1 meat consumed around the world. So the context that we have is production is increasing, and as we know, birds have been selected for faster growth rates, they've been selected for greater efficiency, higher meat yields, and so that's part of this context. Now what that does is that as a nutritionist, this is really interesting because feed is a major part of the cost of production, the total cost of production. So as pressures are being put on for greater production, greater efficiency, we also have a situation where if we can do things differently or do things better in terms of the nutrition that we provide, particularly in the first 7 days, we can have an impact on the overall efficiency of production, both in terms of production efficiency but also economic efficiency. And if we're making these birds more efficient, we can also have a positive environmental impact. So when we're looking at the first 7 days in particular, we need to look at how we provide the nutrients and how efficiently the birds are using those nutrients. So as the chick develops in the egg, and we're going to hear a talk, I believe, on in ovo nutrition a little bit later on. But as the embryo develops and as the chick hatches and grows, we need to address the changing physiology of the bird. And there's a lot of changes that go on in terms of digestive physiology in the first 7 days. Excuse me, I picked up a bit of a cold in the last couple of days. So intestinal development, obviously the intestine doesn't just appear, it develops over time, but the intestinal development really begins early in embryogenesis, in the formation of the embryo. But particularly as hatch approaches, there are a few things that happen that increase the rate of development. So after internal pipping, after the chick breaks through the shell membrane, and starts breathing air, it also consumes the remaining amnion. So it's a consumption of the egg white that is remaining, and that presence of nutritious material in the digestive tract stimulates development of the gut in terms of gut size, but also in terms of gut function. So if we look at intestine weight as a proportion of body weight, you see from 17 to 20 to hatch, 17 days of incubation to hatch, there's a substantial increase in the gut as a proportion of body weight. So when we look at a biological system and we see nutrients or resources being allocated to a particular function or to a particular tissue, we recognize that there's probably a reason for that taking place. So as the gut is growing faster than the rest of the tissues, that tells us that gut development is very important. And so that makes sense because the chick or the embryo is moving from a situation where it's receiving its nutrients via the yolk and the albumin through Meckel's diverticulum to a situation where the bird is going to be consuming feed. It's important that the bird develops that. Again, if we look at development of the mechanism of digestion and absorption, We look at enzyme function, so maltase involved in carbohydrate. AP is aminopeptidase, so breakdown of proteins. ATPase is going to be indirectly involved in absorption of glucose, and then the glucose transporter itself. We see in all of these a rapid increase, a rapid development in the expression of these enzymes. So again, the gut is getting bigger, it's becoming more functional, it's taking on a greater activity to absorb the nutrients. Well, first of all, to digest the nutrients from the resources it has in the egg, but also the resources it will have available to it as it hatches. Okay, so again, biologically, when we see a tissue growing at a faster rate than the rest of the body, allometric growth, it tells us that something important is happening. So chicks, broiler chicks, layered chicks, turkey poults are precocial animals, meaning when they hatch, they're capable of getting up, walking around, finding food. They are not directly dependent on their parents to provide nutrients. But what that means is, in the egg, the priority for nutrients is development of down, of muscles, of the mechanisms that will allow the bird to get up, to walk around, to find food, to a limited extent to regulate its temperature. And that means that in ovo, development of the gut is necessarily lagging behind. So it's a matter of a limited amount of resources and prioritization of those nutrient resources towards development of muscle and skeleton and the means that the chick will have to get around to find its own food when it hatches. And therefore, there's less allocation to the gut. Now, again, that priority is changing as the embryo approaches hatching. Now, if we look post-hatch, we see that in the first 7 to 10 days post-hatch, the gut continues to grow faster than the rest of the body. So there is allometric growth of the body, of the gut relative to the body. So that, again, is saying the chick has the means to get up, to walk around, to find its own food. It's not dependent on the hen or the parents to find food or deliver food to it. But what it means is the gut has to catch up to the other systems in a manner of speaking. So after hatch, the priority for nutrients is the gut. And so the gut is growing, it's developing, it's maturing, it's allowing the bird to make better use of those nutrients that it is able to walk around and find. Now again, this is not saying that there is not muscle growth and feather growth and things like that. Of course that's happening. But the priority for nutrients is gut development. And then once we move past that initial week or two of life, you see that proportionately the gut growth slows. So other tissues are starting to develop faster. First of all, because there's less of a priority for gut growth as the gut matures. And second of all, the nutrients that this now maturing gut is able to provide will support growth of other tissues, of feathers, and particularly muscle. And so if we look at this data a little bit different way, or it's actually a different set of data, but a little bit different way, you can see along the bottom here, no, you can't see. But if you look along the bottom, you can see that the gastrointestinal tract is increasing as a proportion of body weight and then decreasing. And if we look towards the upper right corner, we can see that the increased digestive and absorptive ability of the chick is in fact allowing for greater development of muscles. So the gut size is increasing very rapidly early on. If we look at this not in terms of weight, but in terms of organ length, so this is split amongst the duodenum and jejunum, the ileum and the ceca, and you can see again as a measure of length per unit body weight, the jejunum increases a little bit in the first few days and then decreases. But again, as the length is increasing, as the length as a proportion of body weight is decreasing, it's indicative that the rest of the body is growing faster than the length. Okay, so we can look at gut development in terms of the length. We can look at gut development in terms of weight. We can also look at gut development in terms of the villi and the number of villi that are present per unit of surface area after hatch, and the development of those absorptive surfaces. So if we look in the top left corner, we see the number of crypts per villus, crypt cells per villus, and that increases. And those crypt cells are the progenitors of the enterocytes that are going to be absorbing, producing some digestive enzymes. And you can see that there's an increase in villus or crypt development. We see the same thing with the number of cells per crypt and also the villus surface area. So part of that expansion of gut size in the first week to 10 to 14 days is not just a bigger gut, but an increase in the surface area, the absorptive surface area, and an increase in the number of cells that are being developed. So again, we're not just increasing the size and making nutrient digestion and absorption more efficient because there's simply more gut tissue there, but also because that gut tissue is increasing in terms of digestive enzyme function, and it's also increasing in terms of the number of cells that are capable of digesting and absorbing the nutrients. Okay, so far we've seen rapid gut development happening before hatch. We've seen chicks at hatch having an immature digestive tract. And so they have prioritized nutrients towards development of muscle and down and skeleton and the ability to get up and move around and find food. And that has meant that gut development has perhaps lagged behind. And this is not a fault. It's not a bug, it's a feature, right? So it's the ability of the chick to find food. And this is different than, of course, the strategy of precocial birds. Songbirds, for example, if you've seen songbirds after they hatch, they're naked, they're ugly, they can barely hold their heads up, and they're dependent on the parent to bring them food. Now, the strategy in precocial birds is to have a very developed digestive system. So they are capable of digesting and absorbing nutrients from adult food very efficiently. And so their priority has been towards development of intestinal function rather than muscles and down and skeletal system and so on. So we need to remember that as we look at the development of the chick. The priority in the egg for the chick is to use the limited amount of nutrients that are available to develop primarily the systems that will allow the bird to get up, to move around and find food. And we need to encourage that. We need to make sure that when that chick hatches and it finds the food, that it is able to digest and use it and absorb it efficiently. So what goes into being able to digest and absorb and utilize that food efficiency? Well, part of it is obtaining food. The chicks have already taken care of that because they're able to get up, they're able to move around, they're able to look for food. And so that part of it is taken care of. The next part of it is once they obtain the food and once they consume the food, what's happening in terms of the ability to break down the fairly complex structures, the fairly complex structures that they're going to be consuming the nutrients in and absorb the released nutrients. So if we look at some enzyme systems in newly hatched birds, you can see trypsin is the middle line. Actually, it's on top on the legend, but trypsin is the middle line, and it increases fairly substantially. If we look at amylase, amylase increases very rapidly, more so than trypsin, and lipase tends to remain quite low. And so this informs us how we feed or how we should be providing the nutrients. So relatively quickly, the ability to digest and absorb starch, relatively quickly, the ability to digest and absorb protein develops, but the ability to digest and absorb fats lags behind. And so one of the things that we need to keep in mind as we're feeding birds in the first 7 days is that limited ability. We need to make the fats as digestible and absorbable as we possibly can. So if we look at pancreatic enzyme production, so this first set of figures represents the enzyme production per gram of pancreatic tissue, and we can see that as the bird ages from 1 day up to this is going to 120, but you can see along the bottom excuse me, you can see along the bottom the development over time, particularly in the early phase of life. The amylase and trypsin and chymotrypsin are increasing fairly substantially early on. So that's a maturation of not the digestive tract, but a maturation of an accessory organ, the pancreas. If we look at the expression on a body weight basis, so this is enzyme production per 100 grams of body weight for both, or for all of amylase and trypsin and chymotrypsin, there is that increase early in life and then a decrease. Now remember, this is proportional to body weight, so it's not that the birds are losing this enzymatic function, it's that as the digestive capacity is developing, the bird is more efficiently able to provide nutrients to support tissue growth, to support muscle growth, and so as a proportion of body weight that goes down. But this very clearly shows a development, a maturation of the digestive capacity and absorption. So if we look at the digestibility of carbohydrates, we see we see a change with age. Interestingly, we see from 0 to 2 on to 3 to 4 days of age, we see a little bit of a decrease in energy release from carbohydrate sources in broiler chicks. But then if we look beyond 3 to 4 days up to 21 days, there's a substantial increase again in the ability of the chick to obtain energy from different carbohydrate sources. One of the things that I'll point out is that a source, a fairly simple source like dextrose, so this is a dextrose soybean meal diet, there's relatively small changes in the ability of the chick to access the energy in those diets. As we feed more complex structures, and probably more so what it's related to is also the fiber content, but in more complex diets, so dextrose is obviously very simple carbohydrate source, but as we look at more conventional carbohydrate sources that are more complex, have more fiber to interfere with the access of enzymes to substrate, we see a much greater impact of age. So as the birds get older and we feed them typical diets, we tend to see a fairly substantial increase in the ability of those birds to access the energy. We see a similar situation with protein digestibility. So in this study, they were looking at soybean meal versus canola meal. Canola meal is on the left. And if we simply look at crude protein digestibility of canola meal, it increases from 14 to 42 days of age. Obviously, this is beyond the 0 to 7 days, but we see a similar sort of thing, or we would see a similar sort of thing looking from 0 to 14 days or 0 to 7 days of age. If we look at the digestibility of soybean meal, it's higher to begin with. There are fewer anti-nutritional factors, lower fiber content in the soybean meal. And so in terms of overall protein digestibility, we don't see as much of a change. So when there are more factors to interfere to make it harder to digest the nutrients like we have in canola meal, it has a greater impact or there's a greater effect of age on the ability of the chick to digest and absorb the protein. So if we look at individual amino acids identified with the green arrows, you can see that there are increases in individual amino acids. Now, in spite of the fact of there not being an increase in protein digestibility, with soybean meal we tend to see an increase in digestibility with age for more individual amino acids. Okay, so the take home from these two slides, excuse me, the take home from these two slides is that for the first 7 days we need to baby these chicks along. We need to make sure that they're getting highly digestible carbohydrate, highly digestible protein sources, and we need to make sure that we're feeding them a diet that is conducive to that limited gut function and allow them to develop that gut function. Now, I'm from Alberta. We produce a lot of canola meal. Canola meal is a good product, but the older birds are much more able to use the nutrients in canola meal than the younger birds. Also looking at fat digestibility, and this is probably no surprise to anybody that's fed 0 to 7 day old chicks, there's a huge increase in the ability of chicks to digest and absorb fat that comes with age. And so this is looking at 1 to 5 weeks of age, and each of the cluster of bars is a set of oil sources. So highly saturated, we've got tallow on the left and palm oil on the right, but also looking at soybean oil, a tallow soy blend, and poultry fat. And the biggest increase in digestibility of fat, regardless of the fat source, comes from week 1 to week 2. So prior to that, remember, lipase levels are very low. I didn't show it, but bile salt production is very low, which is also important in fat digestibility. So the easier it is for the chick to digest and absorb the fat, the more energy they're going to get from the fat that we provide. And this is particularly important in that first week of life. So we need to pay attention to the quality of the fat. We need to pay attention to the digestibility of the fat. And typically, shorter chain fatty acids and more unsaturated fatty acids are going to be more readily absorbed by the bird and more used by the bird. Okay, so summarizing so far, we've already covered the first 2 points, but the third point is that limited digestibility, that limited absorptive function early in life plays a huge role in the ability of the bird to utilize the nutrients. I'm not going to spend a lot of time talking about the gut microbiome, but we've got another confounding factor here in that the chick hatches with a not necessarily a sterile digestive tract, but a very simple microflora, and that microflora increases in complexity over time. This can have an impact on performance because of the presence of pathogens, presence of microbes that might activate an immune response. And if I had an extra hour, I could spend a lot of time talking about that, but I'm not going to. So I've had to reel myself in. But just recognize that this changing gut microflora also plays a role. This development of the gut microflora, the maturation, also plays an important role. And this is an opportunity that we have to influence the performance of the bird later on in life, because the microbes that are developing, or the populations that are developing at this time, can have a major influence on productivity and also presence of foodborne pathogens later in life. Okay, so I opened talking about what's happening in the future. Poultry production is increasing, and so we've selected for increasing growth rate and efficiency, and I think the primary breeders have done a great job of selecting for health and livability as well. But we have a moving target. We come up with a plan, and the breeders keep changing things, and that's good. That's good for efficiency, but it means it's a moving target, and what we succeeded with last year might not be what we succeed with next year. Now, the good thing is that the primary breeders know 4 to 5 years ahead of time what the broilers are going to be like, and so this is a typical broiler pyramid. I just think it's amazing that in 5 years, one elite line female produces 4 million broilers, but that's one of the reasons I'm in this industry. It's a lot of it's amazing what can be accomplished. So, as the birds are selected for growth rate and efficiency, obviously the number of days to a particular body weight decreases. Now, this only goes till 2009, but it was the graph that I found that showed this progress the nicest. So we have that advancement in productivity. But what that does is it means that the first 7 days of life becomes a bigger part of the overall lifespan of the bird. So the first 7 days becomes more and more important. We've got that fact that it's a nutrient limiting environment because we're providing nutrients, but the bird has an immature digestive tract. So it's a limiting environment from that standpoint. And at the same time, that limiting environment, that limiting time period is becoming a bigger proportion of the overall part of production. So the things that we do in that first 7 days are becoming proportionately more important. It's becoming more and more important to get those birds off to a good start. And nutrition is part of that, and I think Scott might tell us a little bit later about getting birds off to a good start as well. Again, we're singing from the same songbook. Okay, so the challenge for nutritionists is that as the bird growth rate is increasing, as the birds are marketed at a younger and younger age, that means that if we look at the digestive and absorptive capacity, by the time the birds are processed, might not be fully developed. Also, the microbiome may not be fully stable. It's not necessarily a mature microbiome that's stable, and that can influence the allocation of resources and nutrients to immune function versus growth. So again, I don't have time to touch on that, but this is where the context of antibiotics and effective replacements for antibiotics really come into play. So early provision of nutrients and the subsequent development of the digestive tract is becoming more and more important to good, profitable poultry production. If we get those birds off to a good start, if we get the development of a healthy gut microbiome, if we get the rapid advancement in the ability to digest and absorb nutrients, it means those birds will be productive. It means they will be efficient, both in terms of the use of nutrients that we provide and also economic efficiency. And potentially there are carryover effects on health and also on food safety, particularly as it relates to that healthy gut microbiome. So one of the things that we can do, I mentioned the quality of ingredients, I mentioned the digestibility of the nutrients in those ingredients. Another big thing that I think we're seeing more and more of is providing nutrition to those birds as soon as we can. So it's not just a matter of quality of the feed, it's a matter of when can we provide it. This is some work done looking at the effect of a 24-hour delay in food and or water intake in newly hatched chicks. So the control group had immediate access to food and water, and then they had a group on the top right with access to feed but no water, bottom left without feed but access to water, and then on the bottom left without feed and with water, and then the bottom right without feed and water for the first 24 hours. Now it may be fairly difficult to see, but in the control group we've got nice healthy villi. If you look at the blow up on the bottom, you can see an abnormally formed villi, and so that delayed access to feed impairs the ability of the bird to digest and absorb nutrients early in life. Now the bird can recover and do quite well, but again, that first 7 days is becoming a bigger proportion of the total period of production. And as a consequence, that first 24 hours is also becoming a bigger proportion of the total production period. So getting nutrients to those birds as quickly as possible is likely going to be a strategy that will get them off to a good start. So there's a couple of ways of doing it, and again, there's a talk on in ovo feeding a little bit later on, so I'm not going to talk a lot about it. But the idea is that if you can provide extra nutrients to the embryo as it's developing, you can advance the state of gut development, and therefore the chick will hatch with a more mature digestive tract. So if this, in this example, we have birds or eggs that were not injected with anything, and then another group of eggs that were injected with a number of different nutrients, and you can see that the absorption of alanine is increased in the in ovo injected birds. So this is one measure of nutrient uptake, but you can see particularly early in life an increase in the absorption of an amino acid. Something that I think is really interesting, and we're starting to see it more and more, is early access to feeding, either feeding in the incubator or different systems that allow chicks, individual chicks as soon as they hatch, to gain access to feed. So the idea is that when a chick hatches, it doesn't have to wait to get processed. It has access to food right away. And there's some advantages of that, because just as the ingestion of the amnion, and I should have pointed that out in the in ovo feeding slide, those nutrients that are injected into the egg are injected into the amnion. And so when the chick swallows or consumes the amnion prior to hatching, it's also consuming those extra nutrients. Now we have a similar situation here. If the chick has access to feed immediately after hatching, it will speed not only the provision of nutrients, but it will speed gut development, because the presence of nutrients is one of the major factors that stimulates development of the increase in gut size and growth and expression of digestive and absorptive systems. Another possibility may be to provide moist feed. Now there are some logistical issues obviously with this, but The idea is that one of the things that has to happen before digestion can take place is we feed dry diets typically. One of the things that has to happen before digestion can take place is hydration of the hard, dry particles. So if we can pre-hydrate the feed, we may be able to increase the rate of digestion, increase the efficiency of digestion. And this graph shows that if given a choice, birds consume far more feed as wet feed than dry feed. And if we look at the effect on body weight, if they're only given dry feed, let me put it a different way. If they're given a choice between wet and dry at the same time, they will consume more wet feed, but they will also gain 10 to 13% more body weight or average daily gain. So this is something that's maybe a little bit more difficult to implement. This is used in the swine industry, so it's not completely unheard of in production agriculture. We can supply exogenous enzymes to support the enzyme production that the chicks already have. So things for enzymes for starch digestion and protein digestion are already available. We've seen far less in terms of lipid digestion, and I think maybe there's an opportunity there because lipid digestion is so limiting in the newly hatched chick. We can also feed enzymes that decrease anti-nutritional factors, things like phytate and fiber. Those are obviously widely used already. So if we're feeding the broiler of the future, we're going to potentially see rapid growth-associated problems, metabolic problems, and skeletal problems. The primary breeders have done a fantastic job of selecting for health. When I first started working with poultry many years ago, metabolic problems and skeletal problems were a huge issue. And now, even though the birds are growing faster, they're doing better in terms of health. The issue right now is meat quality. We need to look at what are the ways that we can get the rapid growth and maintain meat quality. And that's beyond the scope of my talk today, but I think it's something we all need to keep in mind. I mentioned the microbiome. We need to continue to look for effective replacements for antibiotic growth promoters, and I could talk another hour about that, but I won't, Ryan. So, and then we have to recognize, and I think we need to keep this in the back of our minds, there are biological limits. A colleague of mine, Martin Zaidoff, has calculated with the current rate of progress in terms of growth rate, by 2034, I think, we will hatch chicks, put them in a truck, and drive them right to the processing plant. So obviously that's not going to happen, but we have to keep in mind those biological limits exist. So the first week is becoming more important. The biological limits exist, and for now, I think we're still able to keep finding ways to adapt. So we can look for increases in the efficiency of nutrient absorption, particularly in that first week of life. We need to look at feeding strategies, particularly in that first week of life, feeding high quality ingredients, feeding highly digestible nutrients, making sure that we're allowing those birds to turn the nutrients that we provide into product, into muscle, in the case of turkeys and broilers, and of course into eggs in the case of layers. So I think maternal and in ovo nutrition are interesting ways to look. Wet feeding in the hatchery is also an interesting way, and I think there are probably more additional creative ways that we can approach this as well. So I will actually be around for the roundtable discussion. There was a slight change in my pickup time, so I will be able to be here for the roundtable. So I don't know if there's any questions now, or if we're waiting till the roundtable.
Yes, we do have some time for a few quick questions. One in the back.
You touched on gut length, weight, villus height, grip depth in your presentation. We know that antibiotics have a potential growth promotion effect by acidic intestine, allowing for more efficient digestion and absorption. My question to you is, when looking at the literature and trying to evaluate markers for gut health, what is the most reliable measurement to indicate gut health? Is it length, is it weight, or is it that villus height to grip depth ratio?
Can you just repeat? Yeah, so the question is, if we're looking at a measure, a marker of gut health, what the best marker of gut health is, because we know that, for example, antibiotics one of the ways that they seem to work is a reduction in gut mass as a proportion of body weight. So really, there's a couple of things. One is there's less mucin for nutrients to have to get through, but there's also less gut tissue that needs to be maintained. And that's probably one of the biggest effects, is the gut is highly metabolically active. And so the less of that gut that you have to maintain while still having efficient absorption, the more efficient the bird is going to be. In terms of a specific marker, it's kind of like immune function. I also do some work with nutrition immune function. It's how do you measure the immune system? It's complicated. So there are things that we look at different things and try to build a story that is supported by the data that we've got. So for example, if we expect the problem is a breakdown in tight junction, in barrier function, we might look at things like occludin, or we might look at those tight junction proteins. If the problem is, I'm drawing a blank here, but if we expect that there's a different problem, we might look at different things. So is there a greater presence of maybe not even pathogenic bacteria, but bacteria that the immune system is recognizing as foreign and responding to? We may look at pro-inflammatory cytokines, for example. So I don't know that there's a measure, but I think so for example, in looking at antibiotic replacements, we may look at things like tight barrier function, or tight junction barrier function. We may look at pro-inflammatory cytokines and see if we are seeing a response in performance. Is that associated with a reduction in inflammation or maintenance of that barrier function? So that's not really a definitive answer for your question, but it's kind of the reality in my view.
Okay, we're going to have to move on. Everyone please join me in thanking Dr. Korver.
Thank you.